Welcome, everyone. My name is Alex. Today, we're joined by some of our partners like Lacework, LiveRamp, and Estonex for some of their mission-critical uses of Redpanda and how we managed to help them. In addition to that, we're also joined by our engineering team to talk about some deep technical problems that we're trying to tackle here at Redpanda, whether it is from the storage or the transactional layers, or an entire new way of consuming the cloud, which we're excited to share with today. To a large extent, I felt that when we were building Redpanda, we were always trying to answer this question, are we there yet? And by that, I mean, did we manage to make streaming as easy as batch? And so I was reminded of this fun formula by this mathematician, Dwight Berkeley, where he was trying to model the time that his kids would ask him. So if we were to get on a car ride, how long will his kids start asking, hey, did we arrive to that location yet? And, you know, to that extent, it just was stuck in the back of my head. Are we there yet? Did we actually make streaming easy? And so today we're going to talk about the things that Redpanda in particular has tried to tackle for the industry and for streaming to try and make that simplification. And perhaps the most meaningful of them for the everyday developer is the fact that we managed to take 4 systems down to 1. So let's dig a little deep here. When you're trying to come up with an upstream distribution of Kafka, so say Apache Kafka, and we're going to highlight sort of the minimum components that you have to get started for a production setup, right? And so this idea that you need three quorum servers, and so Quorum or Zookeeper or Keep 500, etc. This is a layer designed to keep metadata about the cluster. So which computers are up and running, which computers have crashed, etc. In addition to that, you have the actual storage nodes, the Kafka brokers, and internally they use a protocol called ISR. And so both the coordination system and the storage system, they use 2 separate replication protocols, and they're used for different things. In addition to that, you need an HTTP proxy and a schema registry. And so what the HTTP proxy does is that it's a simple translation layer from a web request into the storage subsystem like Kafka. And then you have the schema registry. And so you go from 1, 2, 3 Zookeeper of Quorum nodes. You now have 1, 2, 3 storage nodes. And then in addition to that, you have an HTTP proxy and a schema registry. And all of that is basically three nodes of Redpanda where everything looks the same. So you go from 4 systems down to a single binary. And to the developer, to the practitioner who's actually typing, hands on keyboard typing and trying to get something up and running, it just feels like distributed system whack-a-mole where the only thing you're trying to do is get a hello world program, right? And so I'm sort of reminded of the kids nagging on the back of the car. Did we get there yet? I was like, well, maybe not, but this is the right start for us. The right start is you have a system that is easy to get up and running. And fundamentally, this is why developers love us. It's so easy to use. It was so easy to get started. And I think, as I think about the systems that I've deployed in the past that managed to sort of get the most adoption, there were the systems that the developers were able to understand completely. And so we'll talk about the replication protocols in a second and sort of the failure modes and all of that comes with Redpanda. But fundamentally, it's just easy to understand that you have one process and you put it on 1, 2, 3 computers and you're done. That's about the deployment model of Redpanda. With that, one of the challenges for all of us that have been working with the streaming for a really long time is trying to understand what happens, sort of trying to understand the historical artifact. And so think that Redpanda, for those of us that come from a SQL background or a database background, think of it like an insert-only table, so an append-only table, where there is no mutability. And so the idea behind a log is that immutability property makes it very challenging to actually introspect because your data grows forever. It never shrinks because it's immutable. And so we had to invent a UI. And so we acquired a company called KOwl. We integrated it into now what we call Redpanda Console that allows the developer to go on time travel across the entire history of their data and pinpoint at a particular section. And because these streaming systems are often used for mission critical systems. What you really want is you want to be able to slice and dice, and you want to say what happened between 2:15 and 3:45 a.m. because there was an outage. And the log is often this source of truth, this sort of unified layer for trying to understand the events in your network and in your systems. And so we're super excited to share that we've now integrated that as part of the entire Redpanda platform. And so this, again, sort of continues to make it easy for people to adopt Redpanda. 3 weeks ago, we took this open source benchmark that it's used by everyone in the industry for every project, whether it's Pulsar or Kafka or Redpanda, to try and say, let's take an unmodified client code and then let's point it at Redpanda just to see how it performs. And at 1 GB per second, and there is an entire session on this, so I highly recommend everyone to tune into Tristan, a deep dive into the 1 GB per second workload. We proved that at 1 GB per second, Redpanda uses half of the hardware and is 70 times faster at the tail latencies. So when you're trying to build products, when you're trying to sort of understand, well, how much money is this going to cost me? We really need predictability. And so I'll highlight a couple of things about predictability. So first of all, you have 3 nodes of Redpanda here. And if you look at the latency distribution, right? So X is the latency distribution, excuse me, Y is the latency distribution, and X is the percentile. Often these are also, this could be interchanged at the axis, but the point here is that if you look at Redpanda, the latency is relatively predictable all the way up to the max percentile. And so typically when you log into other products, this is what the dashboard showed you. Hey, your P99 is looking pretty good. And you're like, wait, but I want to understand the entire latency distributions, because at saturation, when there's a particular anomaly, you need predictability from a system, right? Otherwise, this type of things tend to cause cascading failures. And so at that sort of throughput, which is a gigabyte per second, you're experiencing here 70x lower latencies. And a couple of things to highlight. Note that Kafka has 6 nodes, so it's really using 2 times more hardware. And even when Kafka is using 3 times more hardware, as it's pointed here, Redpanda is still faster. So this is a 3-node Redpanda cluster compared even with the 9-node Kafka cluster, and you still experience lower latency. So I think that in order to build predictable systems, streaming, sort of the elephant in the room is that streaming has been always too expensive. Right? And in part of it is because you always had to historically, not only did you have 4 systems or more to try and understand streamers, you also had to over-provision. Often in this particular, for this workload, you still over-provision 3 times as much, and you get worse latency. And so those are some of the sort of technical challenges that we've been super proud to work on, is predictability at saturation. And so we give up a little bit of the average latency to ensure that you have predictability all the way up to the tail. And so we wanted to highlight this order of magnitude larger workloads so this workload is running on our cloud, and we took a 10 GB per second write with a 10 GB per second read consumer, again, using the open messaging benchmark. And we did a 3-way replication, right? So total, you have a 40 GB per second aggregate throughput in our cloud. And so we just feel super proud. The majority of the workloads, and we wanted to, on the previous slide, I was trying to struggle. I was like, do we show the 1 GB, the 10 GB, the 40 GB, and so on? And I think for most workloads in the world that you are working with right now, the majority of people really do fall within less than 1 GB per second. But we also wanted to prove, well, why not 10 GB per second read and write? And maybe at the next open house, we'll show a 200 GB per second aggregate throughput to sort of continue to break some records in our cloud. Again, stay tuned for a later session with Tristan and Steven on this. As part of this, we're working with a public company, and they sort of aggregated analytics, and they have a 5 GB per second reads and 5 GB per second writes. And to them, the major challenges, in particular in this economy, which was that the number of brokers that they had to manage from an upstream Apache Kafka were 380 brokers, and they brought that down to 24 Redpanda brokers. And so at a scale, I guess the point I'm trying to highlight is that the trend lines continue to expand. So, from a 3-node cluster, and we're, really transparent and trying to be honest with everyone in the world, is that at the low end, when you have 3 nodes, Redpanda still sort of delivers cost savings. But the trend line, as you continue to push the data volumes of your cluster, continues to expand. And for this particular workload of a 5 GB per second write with the 5 GB per second reads, that company was able to use 15x fewer nodes. And today, StoneX is going to share how we deliver basically 5 to 6x actually less hardware than they needed with the alternatives. And so the larger the workload, the larger the gap is between the alternatives and Redpanda. And this is particularly one of the most stark differences that we've seen from 380 brokers all the way down to 24. And so at a scale, low latency and tiered storage gives you the capability to reduce the hardware to the actual working set. At its core, Redpanda is really built using this idea of a thread per core architecture for predictable low latency. And so the idea here is that a decade ago, when a lot of the storage systems were built, they were built for the clock tick of the spinning disk, right? And so you go from high a double-digit milliseconds to single-digit microseconds when you're writing to this particular laptop that I'm giving this talk on, right? And so when you have 1,000x improvement on the actual bottleneck of a streaming storage engine, what happens is you can't eliminate complexity. You can only move it around. And the only place that you move it around away from disk is in CPU coordination problems. And so we thought that we started, and you can see this actually with GPUs too, right? Like GPUs have thousands of cores, and your desktops is hitting the same trend. This has I think 128 virtual cores, which has 64 physical cores and so on. And so when you have 1,000x disk improvement and 20 to 30x more cores, the bottleneck simply shifts. And for us to take advantage of the actual hardware to monitor all the way down to the latency of the multi-queue of the NVMe device, we had to build from scratch. And a thread per core architecture really allows us to think of every core as almost like an independent computer. And this idea allows us to build predictability, because what the keystone principle here is that we can monitor the latency from the NVMe device and propagate that all the way to the TCP connection on the client connection. In addition to sometimes having the opportunity to reinvent the wheel when the road changes, what we've also seen is that we started to work with some adjacent possible use cases, not necessarily in the analytical space, right? It wasn't just about taking logs and shipping them to an HDFS cluster or to S3 or to whatever, any form of log aggregator. What we've seen is that Redpanda, because of the latency properties, is starting to be used in sort of a more foreground use cases where it's not just, hey, you hit a web server and then that writes a log and then that log gets processed sometime later. It's actually a blocking behavior from when you press a button to trade a particular stock, let's say in algorithmic or risk trading. And again, today we're going to be joined by Lacework, where they highlight some of the security implications here, and then StoneX, where they highlight some of the hedging use cases, which is super fun. So stay tuned for that. And so we're also seeing it for oil and gas, where you're taking an upstream, oil rig, and then you're sending it to a midstream, and the pipeline jitter has to be monitored, because if it jitters too much, it actually blows up. And so we're super excited that to be actually able to tackle additional use cases in the operational and transactional space. And the way I like to think about that is that you can still take a steamboat from New York to London and it'll work. It'll fine. It's reliable. It's high throughput. It'll get you there. But what air travel did is it invented entire new industries we couldn't have imagined possible. And so with that, today we're announcing our cloud-first storage engine, probably the most meaningful feature that has landed in this particular distribution, and we're super excited to share it with the rest of the world. What it is that over time, S3 is the main storage engine for Redpanda. And this is a fundamental shift from how we have been thinking about storage, where someone is like, I have a terabyte use case, can you give me 5 computers to make sure I can store the data? Now we say like, hey, hold on a second, those same 5 computers can now represent 12 petabytes of storage, because over time, instead of keeping all the data and deleting it, we simply upload it to a high throughput object store like S3 or GCS in Google, or Azure Blob Store on Azure. And the computers that represent that are running the Redpanda code are only designed to contain your working set. And this is a fundamental departure to how we had been thinking about storage, where now S3 becomes the primary modality of storage. And what we've built over the last 2 years, where we've been working on this particular feature, is that there is no fine print, really. It works with compacted topics, it works with transactions, it works with your regular topics. And because we've uploaded the data to S3, it also allows us to create throwaway read-ahead clusters, or read replica clusters is what we call them. This umbrella of technologies, we call those a shadow indexing. And the reason is that per partition will have an index, but we'll also have a meta index that is a sparse index that allows us to find information really fast, so that when we bring up a read replica cluster, it can simply find the information super fast. And so the key takeaway from a practitioner here is that you can have your operational cluster, let's say, managing your trading application, and then you can bring up a new cluster that connects to S3 directly, and it has zero impact on your operational cluster, but is able to give you, within minutes of latency, the data from your operational cluster. So if you have a machine learning application, if you have AI application, if you have, IoT or any sort of aggregate analytics cluster, you can be sure that nothing that you do to this, throwaway or read replica cluster is going to affect any production. And this is sort of a big fundamental departure from how Redpanda, at least how we were thinking about, cross data center replication, etc. We simply upload it into S3. And at the end of the day, for those of us that have to sign checks for consuming systems, this is the thing that matters. It's like driving a 6x TCO comes from the fact that you no longer have to represent the entirety of the data on local disk, right? So you can take the same 5 computers that only used to represent 1 terabyte of storage, and I highlight this 12 petabyte because we're going to be joined today by one of our customers on the live sessions, where it was them and we co-design. And so with LiveRamp in particular, Mithun is going to talk about the changes that we made to the storage engine to co-design for a larger scale, where they went from a terabyte of data to 12 petabytes being represented by the object store. So just a summary of kind of, the are we there yet idea is, in 2019, we took 4 systems and made it down to 1. In 2020, we built the Kafka API layer and we made it 10x faster. Last year, we built the Cloud V1 and, sort of in private until today. And then, in 2022, we proved that we could deliver 10x lower cost. In many times, it's actually higher than 10x, and so it's really workload dependent. But as soon as you start to hit the 1 gigabyte per second, you really start to see huge differences. Where in the previous slide, we showed that at 1 gigabyte, you start to get 6x, and at 5 gigabytes, you start to get 10x, and so on. And so the rate of change of the line of cost really matters as soon as you start to put any meaningful load into the system. And with that, perhaps the most proud I'm in the life of this company is to announce that Redpanda Cloud is generally available today. And so with all of the things that you actually care about, like SOC 2 compliance and VPC peering and managed connectors, and most meaningful for those of us that care about data sovereignty and data privacy, etc., it's the fact that we allow you to keep your data in your local hard drives while the control plane is run by us. So you still experience Redpanda Cloud by going to cloud.redpanda.com, but the hard drives that contain your data, Redpanda never sees. We only see, say, CPU and disk utilization and this and that, but we never actually see any of your customer data. Of course, that we offer a dedicated offering, which is similar to what you would experience with, let's say, MSK or any of the managed Kafka vendors. But this is a fundamental difference. And I think the most fun is I'm about to give you a live demo of a BYOC where you cannot tell the difference between a BYOC and a dedicated deployment. And so we're about to go into the live privacy preserving demo. This is a pre-created Redpanda BYOC demo. And so, as you can see, you get the Kafka API, the schema registry, the HTTP proxy, a Prometheus endpoint so that you can stream your telemetries. I am so our control plane is in US East, but this particular region is in Europe West 1, and it's made out of 3 particular availability zones, etc. And so let's just create a topic to see how it works and to show the data privacy. So I've just created a topic called tests for, let's see, open house, and I'm gonna go in here and I'm gonna I'm gonna publish a message. So I just published a hello world. Notice that I'm able to see and introspect the message. I'm able to see how much data is being stored in the particular segment, the retention times, the total size, etc. But none of this is seen by Redpanda Cloud. So, you know, this is assuming like a fake organization, which you know, with a made-up organization with the BYOC setting. But this allows you to see, introspect, filter, and aggregate the data in your hard drives, while Redpanda gives you a fully managed experience. So if you want to, you know, scale up the cluster or scale it down or send more throughput, all of that is managed by us. But the data gives, you know, you retain all of the data, which gives you full data sovereignty. With that, I'd love to welcome the entire community of Redpanda to come and try the cloud. So come to cloud.redpanda.com, but first sign up on redpanda.com/try and give our cloud a try, whether you want to deploy a dedicated cluster or a BYOC setup. Come and join us. With that, I'll wrap this talk by, you know, please reach out to me on Twitter or on GitHub. My handle is @emacserno. And as a fun fact, Emacs, it does the maximum error in the Linux kernels, basically negative integer. And so thanks for joining us. I hope that we're able to show, you know, I think we've made streaming really easy, especially in the context of a data sovereign cloud. Thanks everyone for coming. Super excited to continue to share the rest of the talks of the conference with you all.